Welcome to this presentation of the Bridge protocol for linking participants. Hi there, my name is Frode Eika Sandnes. I'm with Oslo Metropolitan University in Oslo, Norway. My goal is to make experimentation simple, convenient, and safe for participants. Imagine that you have recruited a list of participants that you want to include in your experiment. And you need to consult these participants several times, and you need some way of linking these participants. A typical way of achieving this is to use a linking table. However, a problem with linking tables is that if this linking table is lost or leaked, then the privacy of these participants are compromised. So we want some way of eliminating the linking table. In previous work, we solved this by introducing the hide procedure. With the hide procedure, you need to first identify who all your participants are, then you configure the experiment and you retrieve a salt. In this case, it is A. And then you can look up all your participants using the salt and the name, and you will get the ID. And all these IDs are unique to each participant, and you don't need to store any of the linking tables. A problem with this approach is that you might want to add more participants later on after you have started, such as with snowball sampling. That was not possible with the hide procedure. The bridge procedure is trying to solve this issue. So here I have an example. I'm entering John with ID length of 1, and I get a unique ID of 1. Then I'm trying to enter Lisa, and I also get another unique ID. And I'm entering Carl, and I also get a unique ID. And I enter finally Frode, my name. And there I get a collision. So I had to remember this challenge A if I am asked again later. It's also worth noting that this JSON object is something you need to store from session to session. Another feature of both the hide and the bridge procedures are that they can tolerate certain types of input errors, such as simple spelling mistakes as I showed here. For instance, the wrong vowels, double consonants, or even the words appearing in the wrong order. How does this work? We start with the name of the participant. If you have a large experiment, say more than 10-20 people, you probably should use the full name. So the first thing we do is to remove any non-alphabetic characters. In this instance, it's the hyphen, but it could also be full stops. In the next step, we are sorting the parts of the name into alphabetical order. Then we apply the soundex procedure to each of the name parts. And we combine all the parts into one string. Then we have an optional step where we add the salt. More about that later. And this result is sent to a hash function, and we obtain a hash value or a digest. The final step involves truncating the hash value. And it is this result that is the unique ID. When we use hashing, there is always a chance that we might have a collision. Imagine we have the name Lena Hansson, and I generate an ID using the procedure I just shown you. Say I get 99175. And then I add another name called Gunnar Green. So I also end up with 99175. We therefore have a collision because both names result in the same ID. To solve this, I'd simply add the salt, in this instance sand, to Gunnar Green. And when I hash the result of Gunnar Green plus sand, I get a different ID, 26294, which is unique. What I need to store in this table or this JSON object I take away that I store is the original ID 99175, which is associated with the challenge or the salt sand. So whenever I come across an ID resulting in 99175, I need to ask the person, were you asked to remember sand or not? And if their response is yes, says Gunnar, then I can compute the correct ID, which is 26294. This is an example of the object that's stored in JSON format. So as you can see here, there is no personal information. We're simply storing the IDs in green, and then the challenge, which is A in this instance, is stored as A. This is the example that I showed earlier. The bridge procedure requires manual intervention. We need to ask the participants to recognize a word challenge whenever we have a collision. In future work, we are developing the candidate procedure, which attempts to generate unique ideas on the fly without any manual intervention. So stay tuned. Thank you very much for listening, and good luck with your experiments.